Hi everyone, my name's Keaton Anderson and I'm going to talk to you a little bit about IoT Connect today. Before I dive too deep into what IoT Connect is, let's talk a little bit about some of the building blocks that go into an IoT ecosystem. So to start here, you'll see on the left we have devices, and these are the things in Internet of Things. There'll be stuff like a connected doorbell, or maybe more of an industrial setting, you'd have a manufacturing machine that you're trying to track. And those are going to end up needing to be connected to the cloud. And they can either do so via a gateway, or if they have the hardware like a Wi-Fi or a Bluetooth chip, they could connect directly to that cloud platform. And typically when we're thinking of cloud here, our major players are going to be Amazon Web Services and Microsoft Azure. Once the data that's coming from those devices is connected into the cloud, then we're going to want to do something with it. So we'll have all of the information in there, and now we want to try to be able to get some visualizations from that. And that's where this dashboard and decisions on the far right is going to come. So typically these will come in the form of either a mobile or web application. And you're going to want to be able to then push information back down to the devices as needed. So if a machine gets overly hot or something, you want to be able to make sure that you push those updates. So with that, some of the challenge that typically comes inside of developing an IoT application is that taking the objects on the left and going all the way to the right, getting meaningful information out of them, can be a very lengthy process. Unless you have really all the different types of developers you would need, which could include things like an embedded developer, as well as a mobile application web developer, a cloud expert, this can be a really time-consuming process. And so today we're going to talk a little bit about IoT Connect, and IoT Connect essentially will act as some of the glue from being able to make this journey kind of go quicker. So it's going to be looking at it from an acceleration perspective. So let's take a little bit of a look at an example for IoT Connect. So we were just talking about those things that we were looking at. So in this example, I say I have a connected construction light. Maybe I have a platform where we're building a new building and I have these lights that have connectivity in them. Or I might have an industrial gateway that's at a manufacturing plant. And so as I talked about before, the goal with these is we're really trying to get insights out of them as fast as possible. So we want to try to extract things like being able to do site monitoring for that construction site. So I could go in and turn off lights at a certain site if I need to. I can check and see how they're being operated. I can monitor power consumption. Those are activities that I might do within that industrial setting. Similar for the gateway, I might have something where I need to be able to watch a particular machine or a line that's doing manufacturing to be able to make sure that those machines aren't running too hot, which could be a sign that they might be failing. So I might send someone out to do maintenance on them on a low time or ahead of a schedule to be able to make sure that those devices aren't going to fail, which could cause more problems and cost me more money in the long term. So again, this goal trying to get from the things to the business insights as soon as possible. But if you remember back to our graphic before, the key that needs to go in the middle there is some sort of cloud infrastructure that's going to be handled. And so what IoT Connect is going to do is it's going to act as that single pane of glass web experience that's going to help you manage your devices, view and analyze data, and being able to kind of do the things you want to do. And how that's actually going to be built is it's on top of a layer of services provided by AWS. So things like Amazon Simple Storage Service or S3, Amazon RDS, Greengrass. It's going to act as the management platform that will handle all of those. So you don't need to try to figure out what services do I need to be able to call to add a device to IoT Connect. IoT Connect will handle all of that piece for you. And you really just need to be able to get your device connected and you'll start getting those insights. And so going back to my slide from before, you'll see that IoT Connect truly supports the entire development journey. You can go from devices all the way through dashboards and decisions. And what this looks like in a practical manner is that you could take something like a development board and using our quick start enablement be able to immediately set up a dashboard with information like CO2 levels or temperature. And so the summary of this is that IoT Connect is a SaaS application that will accelerate IoT development and deployment. So let's walk through a particular example here. I'm going to hand it off to my colleague, Stephen Detloff, who's going to talk a little bit about our quick start enablement with the Infineon XENSIV kit. Stephen?
Before we dive into the quick start kit, I'd like to highlight this landing page we've created on farnell.com. It's It's specifically tailored for the Infineon XENSIV kit with the PAS CO2 sensor, and it provides an overview of what I'll be covering today, including connecting the device to the cloud, signing up for IoT Connect, flashing a pre-compiled binary on here, and getting a dashboard up and running. So we provide links on this webpage for buying the dev kit directly, signing up for that IoT Connect free trial, and a link which I'll be going through today for the quick start. We also provide an overview of what you can expect from a dashboarding perspective once the device is up and running. And we have over here on the right side an IoT Connect quick start video, which is a summarized version of what I'll be going through here in just a moment. So without further ado, I'm going to head over to the quick start in our GitHub repository by clicking this link right here. So as you can see, I'm now on the Avnet-IoT Connect GitHub site, and I'm specifically within this repository listed here. This repository contains the information I'll be going through today, including the developer code and the various guides. If I scroll down to the bottom of this page, we have a short README section, which again reiterates what is covered within this repository. We reference the dependencies that this project relies on, and again highlights the supported boards. In this case, this specific repository is geared toward the XENSIV kit with the PAS CO2 sensor. Also, at the very bottom, we have the instructions. There's 2 bullet points here. The first one is what I'll be covering today. This is the quick start document, and this is a document which walks through connecting the XENSIV board with the PAS CO2 sensor to the Avnet IoT Connect platform using a pre-compiled binary. So this means there's no requirement to install a developer environment, full IDE tools, and everything that goes along with compiling projects from source. We provide the binary file, we'll configure that using a serial terminal, and we'll get that board connected to our platform very rapidly. However, if you'd like to further develop on top of the code we've provided or compile code from scratch, you can follow along with the developer guide document here, which goes into more detail about setting up environments and compiling the code. But again, for today, I'll be following this quick start guide, so I'll go ahead and click into this guide to get started here. The first section here in the quick start guide is the introduction, which is really just outlining what we're going to accomplish today, which is connecting the XENSIV board to the Avnet IoT Connect platform, but did want to highlight that we're also leveraging the Infineon Optega Trust M secure element to provide that hardware security. Moving to section 2, this is the prerequisites. So this guide has been tested with the following environment setup. However, it should be compatible with other operating systems as well. For today, I'll be using a PC with Windows 10. You'll need to have a USB cable, either A or C, but it needs to attach to the board with micro USB. So you'll want to make sure you have a micro USB cable to a compatible port for the computer you'll be using for this guide. You'll also need a Wi-Fi network with internet access, and this is to allow the XENSIV board to communicate with the internet and provide that data to the cloud platform. You'll also need a serial terminal application. I've recommended Terraterm here, and I'll go into a little bit more reasons why as we move to the configuration section, but it's also compatible with other browser-based applications such as Google Chrome Serial Labs terminal. Importantly, you'll need a registered MyInfineon account, and this will enable access to download the Modus Toolbox Programmer. So if you don't have an account, you can follow this hyperlink here, set up that Modus Toolbox MyInfineon account. You'll also obviously need the XENSIV PAS CO2 kit. The next section we'll move to is the hardware setup. This is fairly straightforward. I'll jump down to the section and minimize this window. I do have a webcam set up highlighting the XENSIV Connected Sensor Kit box. So you'll see a box, if you don't already have one, this is what the box looks like. It contains the 2 boards that you'll see on the screen here. On top we have the PAS CO2 censored kind of daughter board, and we have the XENSIV main board with the main MCU on it. These boards can be connected either way. You can put either board on top. I prefer to actually put the PAS CO2 sensor board on top, which provides easy access to the reset and the user button. However, you can choose to put it together however you'd like. And then you'll also need a micro USB cable, as I just mentioned prior, that and the other end should be compatible with the ports that you have on your PC. So next I'll move to the flashing the firmware section. So at this point you should have the board, the daughterboard connected, you should have the USB connected to the board and to your PC, and then we'll move again to section 4 here about flashing the firmware. You'll see over on the right side of the screen that I've connected the PAS CO2 sensor board directly to the XENSIV MCU board using those built-in headers. And I've also connected the main board to my PC using that micro USB cable. And I have some LEDs illuminating there indicating that power is there. So if you haven't already, make sure if you have a board, you've connected those together and got that connected to your PC successfully. Then we can move back over to the left side of the screen and start bullet point 1, which is downloading and installing the Modus Toolbox programming tools. You can just go ahead and right click on this, hit open in new window or open in new tab, and then select the installer that's for your operating system. In my case, obviously I'm using Windows, so I selected the Windows installer. And a point of note, I've tested this with version 5.1. I've noticed that the Modus Toolbox programming tools, the interface changed very slightly from some of the older versions, so I do recommend you update to 5.1 if you're not currently using that version. Next, you'll want to download and save the precompiled firmware. So we provide all the code that we'll be using today as in a pre-built binary in a hex file format. So go ahead and just right click here and you can hit save link as and then save that hex file to a location that's easily accessible. I will note I do recommend putting this in kind of the root of your drive and not to have it in a auto-synced location such as a Dropbox or OneDrive or other similar applications. Sometimes that tends to mess with the installer, so just make sure you put that in a root drive of your computer. And then we'll want to go ahead and launch the Modus Toolbox Programmer. So it will show up as a, here's the icon here, Modus Toolbox Programmer 5.1. You'll see I've already pre-downloaded that hex file. Here is the installer for the programmer, but here's the actual just shortcut to the actual executable. And I have all these files stored just in a folder called C Infineon XENSIV. So I'll go ahead and launch the programmer here. And once you launch the programmer, if it's the first time launching the programmer and or connecting it to the XENSIV board, you will likely get a prompt to update some firmware. So you can go ahead and just hit OK on that, and it will go ahead and update the from factory firmware on that board. And then once that's done, we can continue on with the next sections of this guide here. So again, we'll want to make sure that we configure the programmer to talk specifically to this board, and I've outlined the major points you'll want to make sure are correct here. So you'll want to verify that KitProg3 is displayed up here in the programmer dropdown. And then you'll want to make sure you click the dropdown next to board and select the item starting with CYS, BSYS kit if it's not already selected. Again, this is at the top of the programming tool here. You'll want to go find that in the list and make sure that this is the board that's selected. Next, we need to tell the programmer which file we want to program to the device, and we do that by using the Program Settings section. So I've got that highlighted in here. On the far right of the screen, you'll see a couple dots. You can click this little icon and then navigate to that hex file that we just downloaded a moment ago and hit open, and that will, you want to make sure that loads in here and you see that correct path to that hex file. And if everything is set, you've made sure all these drop-down variables are correct, let's go ahead and hit connect. And you can see I have a disconnect option now, which means I've connected to the board successfully. I don't see any red errors, so we're good to go here. Next, you'll want to go ahead and just hit the program button. And the program button is going to take that hex file and, unsurprisingly, flash that or program that directly to the board. You can kind of see it does an erase and then begins the programming process. And I see no red errors. I see some messages regarding programming finished. So it looks like I am good to move forward to the next section. And in that section, we'll be setting up the serial port in the terminal serial application. So I'm going to go ahead and minimize this and minimize these other windows here, and we'll go over here and move to section 5, the serial port setup. So here you'll want to launch the serial application of your choice. Again, I do recommend TerraTerm, but whatever you so choose, you can go ahead and launch that. If you are using TerraTerm, I do recommend you make one change in the settings before we get to the port configuration. So let me go ahead and launch TerraTerm here. You can kind of see it on this window over here on the right. And this is to enable local echo. So when we're inputting commands into the terminal and we're pasting in commands into the terminal, it's not going to be echoed back to us automatically by the application on the device. So turning on local echo will ensure that as we type, those characters are visible on the screen. So I do recommend going and clicking on Setup here at the top, and then choosing the first option, which is Terminal. And then in here will be an option for local echo. So I recommend right in here you go ahead and check that and hit OK. Next, you'll want to configure the actual COM port for connection. Again, this will vary based on the application you're using, but if you're using TerraTerm, you can go ahead and hit Setup, Serial Port, and then just make sure all the drop downs here match what I've specified in the port setup guide here. So once you've done that and you've connected that, you can go ahead and select a new connection. And when you go to select a new connection, you'll notice that I have some built in to my PC, some Intel Active Management port. But we'll want to be looking for something that says Kit Prog 3, just like we saw in the programmer tool. So go ahead, click that, click OK, and then the first thing you'll want to do is flip back over to your hardware board and press the RST button or reset button. If you put that PIS CO2 sensor on top, that will be very visible right at the very top. It will be the white button right here closer to the USB connection. So I'll go ahead and click on that button here, and I'll minimize that window. And if connected successfully, we'll start to see some information populate in the terminal, namely the certificate, and we can begin to work on extracting some data from this and moving to the next section, which is extracting the certificate and device ID. So go ahead and click over here for section 6. We'll move to that in just a moment. So if we look back over to the serial terminal application and scroll to the top, you can see that we're starting the application task up here. And the first part of the task that the application runs is to extract the device certificate from the Optega Trust M secure element. And actually our first step is going to be copying this certificate, because we'll use this to authenticate the device with the IoT Connect cloud. So the first step here will be to copy the device certificate information, and we'll want to do that including all of the begin and end lines. So we'll start here by copying the lines as begin certificate all the way down to the end certificate, and I'll go ahead and hit edit copy. We'll want to paste this into a text file, so I'll just go ahead and use Notepad for simplicity. I'll open this up, paste in, and again you'll want to make sure you have that begin and end certificate lines, and let's go ahead and save this. I'll save it in the same folder and call it cert.txt, and go ahead and hit save, and then we can go ahead and close that window there too. The next thing we'll want to do is continue to scroll down in here. So after the certificate, the device will automatically generate a unique device ID for your specific device. So all of these will start with XENSIV dash, and then you'll see a random string of characters here that is unique to the device that you have in front of you today. You'll want to make sure we copy this, because we'll want to provide this information, the device ID, also known to IoT Connect as the DUID, to the platform so it knows which device to expect to be receiving data from. So I'll go ahead and copy this as well by using the edit copy. I'll go ahead and open a sticky note, or you can use a notepad, whatever is convenient for yourself, and go ahead and hit new sticky note and just go ahead and paste that in there so I have that for later. Okay, and then we'll want to take a pause from the serial terminal, and we'll do some more configuration in the IoT Connect cloud setup, and that is going to be covered in section 7. So I'll go ahead and move to that section here. So assuming you received your credentials okay, we'll want to go ahead and use one of the following 2 links to log into the IoT Connect platform. Again, I recommend using the AWS version for today, since that's what I'll be going through. and I hope that's what you registered for. So go ahead and use this link here and open in a new window or new tab, the IoT Connect platform, and use those credentials to log in. When you first log in, it'll prompt you to change your password, so I recommend doing that for security. And then after logging in with those new credentials, you should be presented with the main IoT Connect kind of overview dashboard here. So assuming you're here, what we're going to do first is grab some specific information from your environment. We'll use this information to program back into the XENSIV board, so when we connect the XENSIV board to your Wi-Fi internet, it'll know exactly which account to connect to. The two pieces of information we need are the company ID, or the CP ID, and the environment, also abbreviated ENV. We can find both of those pieces of information within the settings in the Key Vault. I have a reference picture on the left here to indicate where to find that, but you'll just want to go ahead and click on the gear icon here on the left and go ahead and click on Key Vault. In the Key Vault, you'll see at the top here the CPID information. There is some Amazon AWS specific device broker information here and the production environment. Well, again, we'll want to copy these two pieces of information for later use in programming into the XENSIV board. I'm going to bring up that sticky note I had earlier, or you can use a notepad or whatever method is convenient for you to go ahead and copy the CPID and pasting this in the notepad, and then I can use the little copy icon next to the environment and go ahead and paste that on a new line in my sticky note here. So these are all the pieces of information that I'll need moving forward. So with that being said, I'm going to move down here to the next section, which is to take this information and to configure it into the XENSIV board itself. So to do that, let's first minimize the window with the IoT Connect GUI and return to the serial terminal and leverage the notepad or sticky note you have with the information we just gathered from the IoT Connect platform. You'll notice in the terminal that we have a prompt for please enter your device configuration, and this is where we're going to put in the necessary information for the device so it knows how to connect to the platform correctly. So the first option here is to input the type of IoT Connect platform we're connecting to, and in our case, if you've been following along with the guide, we'll be using the AWS version, so you can go ahead and type AWS in here and hit OK. The next step will be to enter the CPID, which we've copied from the platform and I've saved here, so I'll go ahead and copy this, click in here, and then right click to paste it and hit enter. And then lastly, the environment from the platform, we'll go ahead and copy that, which is prod, short for production. I'll go ahead and right click to paste that in here and hit enter. And at this point, we'll want to enter the Wi-Fi SSID, so the Wi-Fi network name that you'll be using for the XENSIV board to connect to. Now this could be your home Wi-Fi, it could be a portable hotspot on your phone, but just go ahead and enter whatever that is in your circumstance. So I'll enter mine in here, and then obviously we'll want to then enter the Wi-Fi password. And as soon as you hit enter after putting in the password, it's going to write those values directly to the board and go ahead and reset that board to use those credentials the next time it boots. So as it starts to load, you'll notice that we do have an option to configure the device, and it defaults to yes. So as the board will boot, it'll use any pre-configured information. If you made a mistake during any of the credential entering information or wanted to change the Wi-Fi password, you'll want to make sure you press Y during the booting of the board. You'll see a prompt to change a configuration. So hit Y, then press enter, and then you can go through that setup procedure again. Again, what we'll look for now is some key pieces of information. So I highlighted those in the box here on the left. We want to make sure that the board is successfully connecting to that Wi-Fi network, it's getting an IP address, and it's getting network time, which is important for the certificate. So if we go overhead and look into the serial terminal output, we can see the key pieces of information we want right here. It is connecting to the network, we're getting an IP address, we're obtaining network time, and it now has an accurate piece of time information. Towards the end here, we will see some errors that pop up here about identity missing, and some failure to initialize the SDK. This is expected. This is because now that we programmed the board, we've told it where to connect to. We now need to go to the platform itself and give it conversely the information about the board that's connecting, and that makes sure that we have an authenticated connection from the edge to the cloud. We'll do that in the next section where we set up the device template in the platform. So I'll go ahead and move to section 10 here, and we'll move to that in just a moment. So again, an IoT Connect device template defines the type of data that the platform should be expecting for a certain class of devices or a certain type of device. IoT Connect device templates can be created from scratch, or they can be created and exported to be used as templates. For the sake of time, I've went ahead and created a device template and made that available here in the GitHub, specifically for the XENSIV device. So we can go ahead and find that link for device template right here. I recommend just go ahead and right-click on that and save link as. And I will go ahead and put that into the exact same folder, Infineon, XENSIV, and it will show up as just XENSIV device template.json. I'll go ahead and save that right to that folder there. Now that we have the template pre-made and ready to load into the platform, I'm going to return back to the minimized window here we just had open a moment ago. And I have outlined the sections on how to create a device template, or import, I should say, a device template that's already been created. So we'll click on the devices icon here on the right, and we'll go ahead and click device. And this whole section of the platform contains all the information and all the configuration settings that are associated with specific devices. So as this loads here, we'll see along the bottom there's a bunch of different options: templates, list of devices, different commands, rules, firmware management, batch importing for importing a lot of devices, and exporting some of the data for these devices. You'll notice right now it's empty. There's nothing in my device list, so I'm going to click on the templates section here down on the bottom left, and it currently says no templates exist, so we're going to go ahead and create a template. So as I mentioned, you could actually create one from scratch just by entering a template code, which is just kind of a template identifier, a human readable name, and you can choose some information regarding the authentication type and the device message version. But since we already have a template pre-created, I'm going to go ahead and just hit import. I'm going to hit browse. I'm going to go to my Infineon folder, XENSIV, and pick the XENSIV device template.json and hit open and hit save. And this will take a moment, and this will load into here. And you'll notice in here, this is kind of the template overview where you can now edit the template I just imported. If I click on attributes, you'll see I'm going to be expecting some version information, the CO2 level, temperature, pressure, and some random data that we send just to keep things interesting. So that's in there. And then also I have some commands that are available, which is the status LED and the warning LED. So the attributes, again, are data that the device should be expecting, and commands are defining commands that we can send from the platform down to the device. So I've defined 5 different attributes and 2 different commands in here. So with that section done, we can move to the next section, which is actually creating a device associated with this template. So that is in section 11 here. Many devices can be associated with one device template. So for example, if there's a deployment of 100 different IoT devices, all collecting similar information, you could have all of those devices leveraging one template, which is telling the platform which type of data is being expected from each of those devices. But for today, I'm just going to be connecting the one XENSIV device, and we do that in this device creation section here. So you'll notice that I'm still in my device template here, so I can just go back one level to the device section. And in the upper right corner, there's an option for creating device. If you happen to navigate away from this, you can follow the instructions here to go back to the devices, the device submenu, and you'll also come back and find this create device icon here in the upper right. So I'll go ahead and click that. And here we'll want to define the device unique ID, which is what we captured earlier on when the application first launched in the serial terminal window, and I saved that into our sticky note. So if I bring back up my sticky note here, here is that device unique ID or DUID. I'm going to go ahead and copy that and paste that directly into the unique ID field. And then for the device name, we can put any sort of name in here that's more of a human readable name. So I'll just call this XENSIV Stevens. Here we go. And then for the template, we'll want to choose the template we just imported a second ago, which is XENSIV Demo. And then entity. Entities are, again, where we can organize different groups or groups of devices or groups of users. If you just created your IoT Connect account, there's likely only going to be one entity available for selection. So just select the entity that's provided to you. And then we want to look to the next section, which is regarding the device certificate here. So you'll want to make sure we click the Use My Certificate is selected under the device certificate, because we're going to be using the one that's provided by the Aptega Trust M, that secure element. So we're going to go ahead and click Use My Certificate here. And then we'll have the opportunity to either select a text file or paste in some direct certificate information. If you followed along the guide from earlier, we did save that to cert.txt, if you recall. So under the device certificate, I'm going to go ahead and hit Browse and go back and find that cert.txt file and go ahead and hit Open. After that, we've done all we need to do to configure the device. So I'm going to go ahead and click Save and View here. And what this is going to do is save all that information regarding my device and bring me to the device view for this specific device here. You'll notice right now it says disconnected in the top right, and that's because the device is still in an error mode here. So we'll want to make sure we go ahead and reset the device and verify that the device is now connecting to the platform. And we'll go ahead and accomplish that here in the next section. And here again, we're going to verify that data is moving correctly and we're getting a successful connection to the platform. So we're going to minimize this and switch back to our serial console here and go ahead and press that white reset button on top of the board again. We'll let this load. It's going to use the configuration we already entered in earlier and reboot. And as this loads, we're going to want to keep an eye out for the specific information shown here on the left side. So the pressure information, temperature, and you will kind of see that in MQTT or JSON format. And actually, as I talk, I look over here and I can see we're starting to get some information regarding some version information, temperature. We're getting that random number value. So now we know that the device itself is connected, and we can see that it's starting to push that information to the cloud. And then we'll want to go ahead and verify that we're receiving that data in the cloud. And to do that, let's switch back to the IoT Connect GUI. We now notice that in the upper right corner, we have the connected in green. And I can switch over here and click on the live latest value, which will show me the latest values for each of the variables. And if I wanted to see the raw data, I could click on live data, and we can see the information that's being passed from the various sensor board here. So now that we've confirmed that the data is indeed being collected, sent by the Edge application running on the XENSIV board, it's being received in the IoT Connect console, and we can kind of see that raw data. We can see the latest value in here. The next thing we'll want to do is to visualize this data. It makes it a little more interesting, and we can start to interact with it. We'll do that by moving to the next section about data visualization. So I'm going to go ahead and move to that section here. And switch back over to the information screen on this specific device. And to take this device data and to visualize it, we can use the dynamic dashboard feature of IoT Connect. Similar to the device templates, device dashboards can be created from scratch, or we can import a previously made dashboard in the JSON format. In the GitHub Quick Start Guide over here, I've created a JSON file format for the XENSIV dashboard template, which will produce a dashboard similar to what we see here in the bottom left. So you can go ahead and right-click on this, save the link as, and then save this JSON file to your working directory, along with, for example, your device template. Once saved, we can use the import function for the dashboard by selecting at the top of the screen here, Create Dashboard. And you'll notice we now have a couple different options. we can create a new dashboard, and a new basic dashboard can be an amalgamation of a variety of different devices all presented on one dashboard. We also have the option for a new device dashboard, which presents information specific from one device, or we can import a dashboard that's been previously made. So since we just downloaded a template, I'll go ahead and use the last option for importing that dashboard. And then we'll want to put in a name. This is a human readable name. We can call it XENSIV dashboard. And then the next step will be to choose the file of the dashboard template, which we just downloaded. So I'll select that dashboard-template and hit open. And after we selected that template, you'll notice we have two new fields that just popped up. One for the device template and one for the device. So to tell the dashboard what type of data to display and from what device, we'll go ahead and say, hey, this is the XENSIV demo template we want to use. And we'll pick the device. And again, since I only have one device, I'll just choose the one that's in here. But if you had a multiple devices associated in this account, you could select the specific one you're interested in for this dashboard. So I'll just select the only one I have. And then at the bottom, there's some additional information you can use to configure it. For example, you could set this as a default dashboard such that when you log into the IoT Connect platform, you're presented with this dashboard immediately. And then you have the option to toggle whether the dashboard is visible only to yourself or to others who may be other users who might be on part of your company ID or within your same entity. I'll leave these at default for the sake of simplicity and just go ahead and hit save. Okay, and now while this dashboard loads, it's going to first present us in the dashboard edit mode. And I know I'm in this mode because I have the option to drag and drop more of these widgets into the screen, and I can pick and choose and move these dashboard widgets around. So there's some different information for live data widgets you can choose. There's another subcategory, other, if you want to put in some stuff like labels, hyperlinks. We can do embedded videos from, say, for example, YouTube. If you want to do some plotting and charting information, we can link in with Grafana. And there's some device auditing information here. So these are all available to customize the dashboard how you see fit. This is how I've currently laid it out right now. For example, if I take a look at each of these widgets, in the top right corner, there's the ability to edit, clone the widget, or delete it. So say, for example, I wanted to go in here and edit this widget. I could go in here and change the line colors. So for example, if I wanted pressure to be orange, I can go ahead and change that to orange and go ahead and hit apply. That will change that to orange. And if I'm happy with the way the layout looks, I'm happy with the gauges I have set up, I've configured that, I'll exit the edit view by clicking save at the top on this dashboard. That's going to commit all the widgets to this specific location. And we'll start to see some of that data start to flow in here in just a moment. So all of the JSON data as it flows, and if I tab back over to the Terra terminal here, we can see this sensor information is beginning to flow into here. And we'll start to see some of these data points begin to update, and here comes the live data as it starts to flow in here. One other feature I'd like to point out that's been enabled on this dashboard is the device command. So earlier when I was talking about the device templates, I had mentioned those are used to define the attributes for the platform to understand the data that's coming from the edge. But we can also use it to define commands that can be sent from the cloud back down to the device. We've enabled two of them for this demo, which is the status LED and the warning LED. These are both LED lights that are on top of the PAS-CO2 board. They're located here near the USB connector next to the user reset button. So I can go, for example, and choose the status LED and pass it a parameter value of on. I'll hit execute on that command. I'll get a command sent pop-up down on the bottom of the screen, and we can see now that I have a status of executed here in the platform. So if I flip back over to the camera view, we have a nice LED glowing here that's been commanded to be turned on. And conversely, I can send it the parameter value of off. Again, we get that confirmation, If I flip back over here, the green LED is now turned off. And just to kind of show behind the scenes, if you were to pull up the serial terminal, you'll notice in the ever-flowing JSON, ever-flowing MQTT data that is, we can find a PAS CO2 status LED off received command. So that was received by the board here. There's a lot more features that are built into this dashboard that I really don't have time to dive into today, but I encourage you to explore. We have the ability to share the dashboard. If I click this, I can create a link that either never expires or expires on a certain date, and I can send that via email or however means you'd like to other users to show them this dashboard. And they don't even need to have an IoT Connect account. You can use this for showing to customers or anyone who might be interested in seeing a dashboard that you've created at trade shows or wherever it might be useful for you. You can also export a dashboard here by using this button, and we can save it as a JSON format, similar to what we just imported here. And there's a lot more features. I would encourage you to look a little bit more into the help site that we have, which you can find on the left side panel over here. We can just go over to resources here. It's the 3 different people. We have more information on the SDK. We have some information in our knowledge base and the overall health of the platform. You can get some good information on how everything's working. As a quick recap, what we've gone over today during this quick start guide, we've basically taken a fresh out of the box XENSIV board. We flashed it with a custom piece of software in a hex file format that ran a small user application. That user application allowed us to rapidly connect that board to the IoT Connect platform, move some telemetry very rapidly, and create a dashboard to visualize that data that's being sent up from the edge there. So hope this was a good experience for you, and we'll talk a little bit more about the platform here in just a moment. I'd also like to point out that the XENSIV kit has been pre-integrated with Infineon's Modus Toolbox. If you're not familiar with the Modus Toolbox from Infineon, it's essentially an ecosystem that combines things such as software and tools to facilitate the rapid development and deployment of applications. Within the Eclipse IDE, you can choose the project creator, and when selecting a board, you'll be able to see if there's an option for IoT Connect support. This will automatically grab the correct files from our GitHub repository and help build a project for you. And lastly, I'd like to highlight some additional connected experiences we've enabled with IoT Connect. The XENSIV kit shown at the top is what we went through today. I just wanted to note that we also have a developer guide if you're interested in making some tweaks and compiling your own code. If you're interested in learning more about the PSOC 6, we support the Wi-Fi Bluetooth Pioneer Kit. We have both a quick start guide with pre-compiled binaries and a developer guide for that board as well. And then really exciting, we have support for the Artificial Intelligence Evaluation Kit. So working closely with Infineon's product team, we were able to get early access to this hardware and already pre-enable this board and support 2 different demos that we have hosted on GitHub. One is for a human activity monitor, and one is for a baby cry monitoring demo. Again, these are both available on our GitHub. And lastly, in the bottom right, there's some additional kits that we support, and we'll provide links to all of these kits on our GitHub site. So that about wraps up this webinar for today. I think we'll now transition to the Q&A section. Thank you.